let C be a smooth curve with parameterization R of t for t is between A and B. And let F be a continuous force field over a region containing C. The work done by the force in moving an object from A to B, where A is this initial point when time is A, and big point B is the point R of B is pointing to. So we're moving from A to B along C. The work done is, well, the line integral through the vector field. And the idea here is that at every moment along this curve, the amount of force acting in the direction of motion is what we're adding up, and that is F dot T. So that's the amount of force times a little bit of length that gives us a work. This path integral is adding up a whole bunch of works for us. So this is the work done by the vector field F as we move from A to B along this particular path. Now, as we've talked about, that's a very nice definition formula for a line integral, which through some arithmetic became this formula. So this is also a very nice way of thinking about work, which became what I like to think of as a calculation formula, where I get to write the path integral in terms of the variable t, where I have f of r of t dot dr dt there, which became a parametric equation. So I could actually write down this. This is actually what we would call the scalar differential form. The next one is going to be a parametric form. Because I know that I can write M, N, and P, where I'm thinking of those as the components of my vector field F. I can plug R of t into those and get them in terms of t. So I could actually write this like this, where this would be M times G prime of t plus N times H prime of t plus P times K prime of t, and then all dt. And that integral would be from A to B. And here I'm thinking of G, H, and K as coming from my parameterization R of t. All 1, 2, 3, 4, 5 of these are ways we could think about work being calculated, but they really are just all a path integral. In our next video, we're going to do an example where we calculate the work done in moving an object along a path through a vector field.